So just to summarize linear regression, whenever we want to build a linear regression techniques, there is like one input and there is one output, and we just try to build a some sort of relation between the input and output, and the machine is trying to learn the relation between those two variables. Once the relationship is built, based on only a input, we are trying to predict the output values. So this is what we usually do using the simple linear regression. There is no much difference between the simple linear regression and multiple linear regression. Only the difference is in a simple linear regression, we have just one input value and one output value. And in a multiple linear regression, we have the multiple input values or maybe independent variables, you can see. And this is the equation line for the simple linear regression. Y is equal to beta naught plus beta 1 plus x, and we can also add the error term over here. So error is generally denoted as a epsilon value. So beta naught is a slope, beta 1 is intercept. So these are the two values that we are interested to calculate. So let's just understand how exactly we can calculate. So we just started yesterday discussing about the ordinary least square method. So let's just understand what does that mean and how that particular method would help us understanding or maybe helping us building a best linear model. Suppose for example, on a y-axis, so here you can consider the temperature is our y value, and this is our sorry, this is our y value and this is our x value. So we want to predict the ice cream sales based on the temperature value. So like suppose we are running this ice cream sales shop and we want to check like at a specific, like suppose today's temperature degree temperature, let's consider is a 20 degree. So how much ice cream I could able to sell with that. Let's consider that, oh, here is 20, here is something like 50 or maybe up to 100. So for example, for the 20 temperature value, I'm able to sell something like this, or maybe the values will come up over here like this. So our like, and we want to guess the prediction. And as a business owner, we want to understand if the today's temperature is a 50 degree, how much sale can happen for the ice cream. So this is what I want to predict, or maybe I want to guess. So we do have the history data of the ice cream sales, previous history data, and the temperature. So based on that, we will try to build some relation between the y and x, and that relation could be a linear relation, because we are going to build a simple linear regression model. So relation could be a linear relation, means suppose x increases, y would increase, x decreases, y would decrease. So this is some sort of positive relation or maybe a negative relation, but there would be a straight line relation or maybe linear relation you can call. And let's just understand, for example, I build this particular line over here. So for that, you can consider the estimated line or maybe predicted line of this ice cream sales. So this is the particular line which I built. So wherever there is some value new comes, for example, I want to see what could be the predicted value when I have the temperature 30 degree. So for the 30 degree, I want to check what could be the prediction. So I'll just go something like this over here. So this is my predicted value. So y can be here. Let's consider we are considering the ice cream sales as per the quantity or maybe a price. Like if we just consider this as a price, so let's consider the 200 or something price is over here. So we'll just draw the some intersection for that particular straight line, and we will try to predict the y value based on this line. So this line is nothing but our y hat or maybe a predicted line. So wherever we want to check something, temperature between 1 to 100, anytime somebody suppose give us the any value between 0 and 100 for the temperature, we are able to predict ice cream sales value based on this relation. So this relation is a linear relation because we have this a straight line. You can see over here it's not a linear in terms of straight line. It's not some other relation, for example something like that, curvature or maybe a down curvature or maybe something like that. So we do not have this, we have just a straight line here. So for that we do call it as a linear relation. And our job is guess the prediction for the, for example for the 50-degree or maybe 30-degree temperature or maybe same any other value. So this is our problem statement. So, and for that particular problem statement, we have built this linear regression line, or maybe we have built the linear regression model, and based on that, we are just trying to predict the values based on this particular line. So, how exactly we choose this particular lines? Like this is something like I just plot. So it's not the situation that we usually directly plot the values. Sometimes the line can be this one, sometimes line can be this one, or maybe this one. So we usually plot multiple lines in a Python or maybe in a machine learning in the backend of this line. Over here you can see this is the regression. We are trying to learn the relationship over here. So learn the relation means we will plot so many lines, and based on those lines we will try to select the best line. So this is what we do using ordinary least square method. So ordinary least square method is nothing but the method which actually help us selecting the best line. So best fit line means what exactly the meaning of best fit line? So base fit line means this is the values which we previously were having, the temperature values. So we will try to calculate the distance between this value and this value. So everywhere we will try to calculate the distance. So let's consider that this is x1, the distance is somehow 0, like this x is belonging on the line itself. This can be a x2, this is the x3, x4. Let's consider this is our x5 and this is the x6. So these are the something like that. What exactly ordinary least square does is it just try to find the best line so that we can minimize the distance between these each point, each observation you can consider over here. For example, for the 20-degree temperature, we have the price, it's like for example 10-degree temperature, we have the x1 value, or maybe observation for the y cells is something like that. Let's consider this as a $50 or maybe something. For the 20 or maybe for the 25 temperature, we have the value which is lying maybe around $300 or maybe something like that. So this is the data which we already have. So this zero, like zero, this dot sign is nothing but the ice cream sales value in a price, and this is nothing but the temperature. So we will just try to find out the best line so that we can minimize the distance between these points as much as possible. We can reduce the distance. So it's nothing but like suppose there is few observation over here, and we see that for example this particular line has the minimum distance from this particular point. So distance we don't usually calculate for the single value, or we could not give the weightage for the calculating the distance for the single value. We usually calculate distance for the each and every value, and the distance you can consider this as a di. So predicted value you can consider over here, this is the actual value, and then the predicted value for that you can consider the y hat. So you will just try to calculate this particular distance, and there are multiple methods to calculate the distance. We can directly do this some squared sums, or maybe we can do the like mod of the di minus this particular, or maybe we can do the y minus y hat square. So these are the multiple. Standard way is this which we follow for the linear regression is this one. We do the squared distance between these two values, and we do calculate this particular square distance by using the d bar is equal to, for example, let's consider this is the one of the distance d1 squares plus d2 squares plus d3 square. So this is how we do calculate the distance, and based on the each total sum of square distances, we try to choose the best line. So over here you can see we are not giving the weightage for the single value, we are giving the weightage for the all the values. That's why we are just doing the summation over here for the each and every value. For example, let's consider this is the line 1 L1 and this is the line 2. Looks like few of the observation, the distance for the line 2 for the few of the observation is minimum, and but for the another observation it can be a maximum. But with the line 1 we are trying to uh, choose the line for that particular line. For the each and every observation, distance is for the sum of them distance is maximum, but averagely distance for the each and every point is minimum. So based on a total sum of squared distances between the actual value and predicted value, we just do the or maybe perform the this particular calculation. And whenever we see that there is a minimum distance for that particular line, so we choose that line. And for the entire calculation or maybe entire this stuff, doing this calculation square sum distance and all those, we do call it as a ordinary least square method. So ordinary least square method is nothing but which help us find the best fit line. And we usually how exactly we do find the baseline is we find how far each data points from that particular line. So for that we can say in other words that we calculate the distance, and once we find that particular distance, our next task is minimize the, like find the baseline so that we can minimize the squared distance or maybe squared sum, so which we have already calculated over here. So we'll just try to find the baseline so that we can minimize the squared distances or maybe total sum of square distances from that particular line. So this is what we do. And why exactly we do the square? So as I already told you, there are two methods. One is we can directly do the absolute values, and another one is we can do the squared value. So those value, both the values actually help us for the getting the actual sum. Like for example, the distance over here can be negative, distance over will be the positive. So positive negative positive negative, it should not be sum up to some negative values or maybe something. So that's why we do convert those value into the positive values. So only for that particular reason we either choose this modulo of formula for calculating the distance, or maybe you can we can choose the squared distances. So these are the two ways we can choose so that we can get rid of negative values. So another one is in our line we have this b naught and b1. So b naught and b1 is once we find the best line, you can see that the intercept of this particular line is over here. Sorry, like this particular line is intercepted on a y-axis over here. For that you can call it as a intercept, and over here it can be a slope. So these are the two things we do calculate when we are actually trying to calculate these coefficients. So these are the coefficients we do calculate, and this is the basic formula to calculate the coefficient. So it looks like more like the covariance or maybe correlation type of formula. So using that formula, we do calculate the beta 1 values, and beta naught is nothing but we just do the y minus beta 1, sorry, y minus beta 1 x, and then we do calculate the average values of that particular y variable and x variable. So this is just a formula of calculating the beta naught and beta 1, and this seems pretty easy when we are working on only a simple linear regression where we have only two values, like one is independent value and one is the dependent value. For example, over here we have the independent value as a temperature, and dependent value is for the cell price calculation is this y is our dependent value. But what if we have the multiple values coming into the picture, just like multiple linear regression, for example, how many hours uh, people are awake so that we can sell the ice cream, or maybe how many family members, or maybe the population of that particular city. So there are multiple variables which can affect on that particular y. So in that situation, it's very hard to go with this particular formula, or maybe a simple way of calculating the beta 1, beta 2, beta 3 things. For that, we need to do a matrix multiplication, or we need to picturize or maybe imagine the matrix kind of thing. So that can be happen using a iteration method. So we can also see that later on.